Good morning, students. Welcome to the computer classes. I am your new computer teacher Arpita Haldar, and I will be going to take your class for this session for class 7. As you know, we are facing this tough time. We are having this lockdown due to coronavirus and we are missing our classes. So, our school has decided to provide you some study materials so that you can continue with your study. So, I will be providing you with one PPT, one worksheet that you will be completing, and I will give you the first chapter as in the PDF format. So you have to see the PDF format, what are the chapters, what are the PPT that I am providing you, and you have to solve those worksheets. This time I will be providing you with only one worksheet, so you will complete those worksheets and I will check your answers afterwards. So now let's start with our first chapter, that is number system. Let's see what are the topics that we are going to study. Number system, decimal number system, binary number system, octal number system, hexadecimal number system, decimal to binary conversion, binary to decimal conversion, and the binary addition. So basically, what is the number system? The number system is simply a system to represent or express number, that is mathematical notation for representing numbers of a given set using digit or other symbol in a consistent manner. So see, 34. 34 is a number. But which number system we are using? We are using this decimal number system. How we will know it? We are using these digits from 0 to 9. 4 is in the ones place and 3 is in the tens place. So how many types of number systems are there? Basically, there are 4 number systems, that is decimal, binary, octal, and hexadecimal. There are other number systems are also there, but we will not study in this class. We will only study these 4 number systems. So what is this decimal number system? Decimal is a term that describes the base 10 number system, probably the most commonly used number system. The decimal number system consists of 10 single digit, that is from 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. In computing, the binary, octal or hexadecimal number system may be used instead of this decimal number system. So, the value of each digit in a number depends upon the following, that is the face value of the digit, the base of the number system, and the position of the digit in the number. Now let's take an example, that is 547. In 547, 7 is in the ones place, 4 is in the tens place, 5 is in the hundreds place. Now how we will represent this ones place? As we know, 10 to the power 0 is equal to 1. The value of 10 to the power 0 is 1. So 7 into 1, that is 7. So it is in the ones place. Now 10 to the power 1, it is increasing from the right hand side. See, 10 to the power 0, then 10 to the power 1, then 10 to the power 2. Now it is 10 to the power 1. 10 to the power, value of 10 to the power 1 is 10. So 4 into 10 is equals to 40. Now 10 to the power 2 equals to 100. Now 5 into 100 is 500. So when we sum up all these numbers, we will get this 547. So let's start with binary number system. So what is this binary number system? A binary number system, there are only 2 digits, that is 0 and 1. And we use this binary number system in our computer. And our computer can only understand this binary number system because it has only 2 states, that is on and off state. That we will know later on. So what are the characteristics? Uses 2 digits, 0 and 1, also called base 2 number system. Yes, binary number system has 2 numbers, so it is also called base 2 number system. So why we will use this binary number system? We know our computer is an electronic device and it is made up of all these electronic components, and it has only 2 state, on state, that we can represent with the number 1, and another is the off state that we can represent with the number 0. The data which is given to the computer is converted into this binary form, that is on and off state, 1 and 0, and our computer can only understand this binary language. So what is this octal number system? In octal number system, there are only 8 digits that are from 0, 1, 2, 3, 4, 5, 6 and 7. So it is also called base 8 number system. Octal number system is one of the type of number representation technique in which the value of base is 8. So what are the characteristics? Uses 8 digits 0, 1, 2, 3, 4, 5, 6 and 7. And it is also called base 8 number system. Moving on to the next slide. Hexadecimal number system. So what is this hexadecimal number system? Here the base is 16. Hexadecimal number system is one of the type of number representation techniques in which their value of base is 16. So there are 6 numbers or 6 possible digits, symbols or value, 16 symbol digits or value, that is from 0 to 9, then A, B, C, D, E and F. Yes, it uses 10 digits, that is 0 to 9, and 6 letters that are from A to F. Letter represents the numbers starting from A equals to 10, B equals to 11, C equals to 12, D equals to 13, E equals to 14 and F equals to 15, and it is also called base 16 number system. Now moving on to the next slide. Now we know this binary number system, we know this decimal number system. Now our computer can only understand this binary number system. So we should know how this computer converts these decimal numbers that we give as input to binary number system. So there are few steps that you will study. Step 1 is divide the given decimal number which is to be converted by 2. Now step 2, write down the remainder either 0 or 1 and divide the quotient again by 2. Repeat the step 2 till the quotient is 0. Now see the example. I will show this example how to solve. Now let's start our first example, decimal to binary conversion. So let's take the first digit, that is the decimal number 25. Now we will convert it to binary number system, that is base 2 number system. So how we will do this? Let's take the number 25 and start dividing it by 2. 2 ones are 2, 2 twos are 4. So what is the remainder here? The remainder is 1. So we will write this 1 here. Again I will divide this quotient by 2. 2 6 are 12. So what is the remainder? Remainder is 0. Now again we will divide it by 2. So what is the number? 2 3s are 6. So what is the remainder? 0. Now again we will divide by 2. 2 1s are 2. So what is the remainder? 1. Now see this. At the end we will either get this 1 or 0. Until and unless we are getting this quotient as 0 or 1, we will do this division. Now we will write this number from this. We will go to upside. We will start from here and we will go to upside. So what is the number starting from this? 1 1 0 0 1. So our required answer is 25 as decimal, and this is the 11001. We will get this as the binary number. Means this decimal number is converted to binary number. Now let's take another example. Now 77. Say this number 77. This is in the decimal number system. We will convert it to binary number system. So let's start. We will take this 77. We will divide this by 2. 2 3s are 6. Carry 1. 2 8s are 16. So what is the remainder? 1. Again we will divide it by 2. 2 1s are 2. So 18. 2 9s are 18. So what is the remainder? Remainder is 0. Again 2 9s are 18. So what is the remainder? 1. Again 2 4s are 8. So what is the remainder? 1. Again 2 2s are 4. So what is the remainder? 0. Again 2 ones are 2. So what is the remainder? 0. Now see this. Until and unless we are getting this quotient as 1, I am continuing this division. Okay. After our division is complete, we will start from here and we will go to the upside to write this number in the binary form. So the answer is 1 0 0 1 1 0 1. So 77 as decimal is converted to binary. When what is the result in binary? 1 0 0 1 1 0 1. Okay. Now moving on to the next slide, we will start with this binary to decimal conversion. You have already studied how to convert from decimal to binary. The next step is to convert from binary to decimal. If you have any binary input, how to convert it to decimal output. So what are the steps involved? Step 1, multiply each number with 2 having the power 0 for unitary position starting from the extreme right. Step 2, increase the power 1 by 1 keeping the base fixed as 2. Now what is the step 3? Sum up all the products to get the decimal number. Example here, 110110111. Okay, this is the number in the binary. So see, this is the extreme right position. That from this position we will start with 2 to the power 0, then 2 to the power 1, then 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. Now see what they have done. 1 into 2 to the power 0. What is the value of 2 to the power 0? It is equals to 1. So 1 into 1, 1. 1 into 2 to the power 1. Okay, next digit is 2 to the power 1. So whatever it is, 2 to the power 1 value, that is equals to 2. So 1 into 2 equals to 2. Now again, next number is 0. 0 into 2 to the power 2. 2 to the power 2 equals to how much? 4. But 0, anything into 0 is 0. Now next number 2 to the power 3. So 2 to the power 3 is 8. So 1 into 8 is 8. Then 2 to the power 4. 1 into 16 is 16. Likewise, we are getting these numbers. After we get all these numbers, we will sum up all these numbers. See, we are adding these numbers. So what is the answer? That is 219. So this binary number is converted to decimal number. And what is the result in decimal? That is equals to 219. See, when we are writing this binary number, we will use this base 2. And when we are writing this decimal number, we are going to use this base 10. Now we will solve another problem. And I will show you one more problem how to convert from decimal binary to decimal. So let's start. Now this is binary to decimal conversion. Now what we will do? See, let's take example 1101. This is in the binary form. We will convert it to decimal form. So let's start with this extreme right position. So I will write this 1, then 0, then 1, then 1. See this 2, 1 into 2 to the power 0. For this position it is 2 to the power 0. For this position it is 2 to the power 1. For this position it is 2 to the power 2. For this position it is 2 to the power 3. From the extreme right we will start and we will move up and we will increase this value by 1. Now see this 1 into 2 to the power 0. Now next is 1 into 2 to the power 1. Then next is 0 into 2 to the power 1. Then next is 1 into 2 to the power 2. And then next is 1 into 2 to the power 3. So what are the values? 1 into 2 to the power 0 is 1. Then 1 into 2 to the power 1 is 2. 1 into 2 to the power 0. This is 0. 0. 1 into 2 to the power 2 is 4. Then 1 into 2 to the power 8. 2 to the power 3 is how much? 8. So we are getting this number 1, 0, 4 and 8. Okay. Now we will add these numbers. 1 plus 0 plus 4 plus 8. That is equals to 4 plus 1, 5. 8 plus 5 is 13. So this number binary number in decimal number system is how much? 13. Did you get it? How to solve? Again I will show you. We will take this number 1101. For this position to the power 0, extreme right position to the power 0, we will increase by 1 to the power 1, to the power 2, to the power 3. Now 1 into 2 to the power 0, 0 into 2 to the power 1, 1 into 2 to the power 2, 1 into 2 to the power 3. Then whatever the value we are getting, we will sum up all those values and we will get this in the decimal number system. Now moving on to the next slide, we will go to binary addition. What is this binary addition? It is a key for binary subtraction, multiplication, division. There are 4 rules for this binary addition. That is, case 1 is 0 plus 0, the sum will be 0 and the carry will be also 0. Now the case 2, 0 plus 1, the sum will be 1 and carry will be 0. For this case 3, the sum 1 plus 0, the sum will be 1 and the carry will be 0. And for this case 4, 1 plus 1, the sum will be 0 but the carry will be 1. See, in the fourth case, a binary addition is creating a sum of 1 plus 1 equals to 0. That is 0 is written in the given column and a carry of 1 over to the next column. Now let's see one example. See, the decimal addition of 26 plus 12 is how much? 38. Now let's convert this decimal 26 to binary. So what is a binary number? 0011010. You know how to convert this decimal number to binary number. Now the next number is 12. We will also convert this number in the binary form, that is 001100. So let's see this one, this area. See, we have written the digits 00111000001100. This is for the number 26 and this is for the number 12. Means this is the binary number system of 26, binary conversion of 26, and this is the binary conversion of 12. Now let's see, 0 plus 0, 0, 1 plus 0 equals to 1. We will see that truth table. You know the truth table? 0 plus 1 equals to 1, and 1 for this 1 plus 1, we know that what? 1 plus 1 is, sum is 0 and we will have this carry. We will give this carry to the next number. So for this number we will add this 1 plus 0, 1, and this 1 plus 1 is how much? 1 plus 1, 0, and we will get this carry. We will forward it to next. So this carry is here. 1 plus 0 is 1, 1 plus 0 again 1. So what is the result that we are getting? 0 1 0 0 1 1 0, because 0 plus 0 is already 0, you know. So if we convert this number to the decimal form, we will get this number 38. So we already know 26 plus 12 is 38. Okay, I will show you another problem with this binary addition. Let's start this another problem. Now let's take these two numbers, binary numbers 1101 and 1001. We will add these two numbers, binary numbers. So let's start it. Let's write these numbers 1101 11001. Now first write this truth table. Okay, so what is the truth table? When A is also 0, B is also 0, the sum is 0, carry is also 0. When A is 0, B is 1, we are getting the sum 1, carry 0. When A is 1, B is 0, we are getting the sum 1 and the carry 0. And when the A is also 1, B is also 1, we are getting this sum as 0 and the carry as 1. Now we will do this addition. See this addition. See, According to the truth table, A is also 1, B is also 1. So 1 plus 1 how much? Sum is 0 but the carry is 1. So what we will do, I will solve this with the red pen so that it can be easy for you. 1 plus 1 how much? 0. So what is the carry? Carry is plus 1. Now see, 1 plus 0, 1, 1 plus 0, 1. So what is the result here? 1. See, 0 plus 0 is how much? 0. Carry, sum is also 0, carry is also 0. Now there is no carry. 1 plus 0, that is equals to how much? 1. And 1 plus 1 is how much? 0. And there is one more carry. So we will write the carry here. So what is the answer? 1, 0, 1, 1, 0. See this number. This number in the decimal form is equal to, see, this number is in decimal form is 13 and this number in decimal form is 9. So 13 plus 9 is equals to how much? Equals to 22. Now let's see this number, if it is 22 or not. For this is equals to how much? We will solve again this in that process. 0 into 2 to the power 0, 1 into 2 to the power 1, 1 into 2 to the power 2, 0 into 2 to the power 3, 1 into 2 to the power 4. This is equals to 0, this is equals to 2, this is equals to 4, this is equal to 0 and this is equals to how much? This is equals to 16. So 16 plus 4, 20, 20 plus 2 how much? 22. The sum is equals to how much? 22. So our result is correct. Okay. So for this addition 1101 plus 1001, the result is equals to how much? 10110. Have you understood this problem? So now children, I am providing you with this worksheet. Now what you have to do, you already know how to convert this and how to do the binary addition. So you have to solve those worksheet and I will check those answers afterwards when the school will reopen. I hope you like this video and it will be helpful for you. If you have any suggestion, you can provide me with the suggestion that what the problems you are facing while seeing this video, so that I can improve my classes. You can provide those suggestions to your class teacher or you can directly contact me also. I will be grateful if you give me any suggestions, because it will be nice for me also, so I can change myself and I can change those I can solve those problems. Thank you students. Have a nice day.